Hello and welcome to this channel. So today we are given a truth table where we have to find out its product of some form, and then we also have to implement its NAND logic using the NAND logic gates, and then we are also going to see how we can implement it using the C code. I will create the executable and run on a app called Termix, which creates a Ubuntu environment or a Linux environment on mobile phone. So let's begin. So given is this truth table. So from the values of G, we can create a K map for the variable G, the output variable G. So this is how it looks. So we want to get two doublet implicants and one single cell implicant. So as we are creating the POS expression, we are more bothered with the zeros. So after looking into these three implicants, we get these three max terms, u plus w bar, and then v plus w bar, and third one is u bar plus v bar plus w. So next comes is we have to implement it using the NAND logic gate. So to implement it using the NAND logic, we have to convert it into sum of product form. So this is what we get in SOP form. On further simplifying, we can take W bar as common, and we get V bar plus U bar into W bar plus UV bar. And we can see after applying the De Morgan law, it boils down to this equation, and this further looks like a XNOR operation between UV and W. So this is how the NAND logic gate implementation would look like. So let's move on to the C code implementation of this POS expression. So now we are moving on to the C code implementation part. We are going to create an executable, and we'll also try to test whether it is working good according to our given truth table or not. So right now in my mobile, Termex app is running. So we're going to create an SSH connection to the app. So this is how you write the command SSH, and the user ID you're going to get from the Termex app, and then IP address of the mobile device, and also the port at which the SSH connection is open. So let's enter this command. I'm putting my password and see we are into the terminal. So now let's log in into the Ubuntu environment, and this is the command how you log in into the Ubuntu environment, which is already installed. So as we can see, we are logged in into Ubuntu. Now I have already cloned the repository which is having the C code. So I'm just navigating into that directory. Uh, and you can see we are having the C code. So what we're going to see is let's go through this code once. What all things we have to execute, how we're going to execute our POS expression. So you can see we have we have created an output variable G, and then we have also uh, created a variable called 1, which we are going to uh, convert our hex values into the bits for, so that we can display it at our final output screen. And then we have taken three variables as our input, u, v, and w, and we have just given it the values 1 0 0, you can see, so that we can check whether for the given input 100 we are getting output as 1 or not, because 1 is the correct value according to the truth table. Let's see what will be the output. So I have implemented both POS and SOP expression in this C code. Uh, you can see with the POS expression, this is how you implement the AND, like dot operators and negation operator and OR operator. You can see similar SOP expression. These both things are given in the PDF. I will be attaching to this video, and then we are printing the input and output for this given input 100. So and why we are doing this AND operation with 1 is we are converting our hexadecimal values to the binary bit, so that we could easily deal with the output and verification could be done. So let's move further and let's execute our C code. And we have we are creating an executable named code for our given C code file, and it's compiling the code. And let's run this executable file. So we can see, as we have given the 100 as input, we are getting output as 1, and this is in accordance with the given truth table, and hence C code has been implemented properly. Oh, thank you.